Greetings to one and all present here, dear authors and invited guests. Welcome to the technical session 5C. Myself, Gargi Kalra, and the session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th World Conference on Smart Trends in Systems, Security and Sustainability, World S4 2023, London, UK. The seventh edition of this conference is being organized in a hybrid mode. The physical event was held in London, UK on 21st of August 2023, and the virtual event is being held through Zoom today and tomorrow, that is 23rd and 24th of August. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On every 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. And just before we start the session, I would like to introduce you all to the chair for this session. Firstly, we have Dr. Pallavi Bhatnagar. She is an associate professor at MIT, India. Her area of research is power electronics, multi-level inverters, photovoltaic, LED drivers, electric vehicles. She is a senior member of Institute of Electrical and Electronics Engineering, IEEE, USA, and a life member of Indian Society for Technical Education, ISTE. The next we have Dr. Thaitapon Genokrenata received the BSc degree honors in media technology from the King Mongkut's University of Technology, Thonburi, Bangkok, Thailand, and the Masters of Engineering degree in Electrical Engineering from Chulalongkorn University, Bangkok. Her research interests include computer vision and machine learning, specifically human-computer interface for surveillance videos. Ma'am, we welcome you both. And if you want to say something to the audience, then you're open to that.
Thank you, Gargi. And a very hearty good afternoon to all of you. I'm Pallavi. A big hello to all the participants and my colleague, session chair in this session. Best wishes to all of you. Good luck.
Okay, so thank you so much for a very nice introduction. So yeah, so it's very nice to serve as the session chair for this conference. Okay, and I see a lot of interesting topics, so I'm looking forward to it. Okay.
Thanks to both of you for sharing your views. So let's start with the paper presentations. Firstly, we have the paper title, A Reinforcement Learning Model of a Dynamic Solar Panel System for Maximum Energy Harvesting, and that will be presented by S.M. Mizanur Rehman. Are you there? I think he is not present right now. So let's move to the next one. The next paper is Analysis of the Problem of Forecasting in Proactive Enterprise Management. Is the presenter there? Kostareb DB. Okay, no issue. Next, move to the next one. And it is Cost Management Model in the Subway and Open Pit Mines, a Systematic Review. Is the presenter there?
Yes.
Yeah. You can share your screen and start the presentation.
Okay. Can you see the presentation? Can you see the presentation?
Yes, we can see.
Okay, I'm going to start. Good morning to everyone present at this meeting. My name is José Morales. I am a mining engineer student at the Universidad Nacional Mayor de San Marcos in Peru. Today, I will present the work title cost management model in the subway and open pit mines a systematic review. The mining industry is one of the most important activities in the world. In addition, it is one of the oldest activities of humanity, and since prehistoric times, man has used various minerals to manufacture tools and weapons. Mining is an important industry that has developed a series of techniques, studies, and physical chemical analysis to improve the exploration and exploitation of deposits. The mining industry in Peru also has a long history of economic and social significance, employing metals since pre-Columbian times. It's a key source of employment and income with recent sustained growth. However, it also faces challenges in cost management and operational optimization. The proper choice of equipment and collaboration are essential. Efficient resource utilization is crucial for sustainability. For this reason, an integrated approach to cost management and operational optimization is sought in the Peruvian mining industry. During this systematic review, it was found the trend promotes innovation and continuous improvement, including the use of technology for this purpose. You can see the mining canon had its highest peak in the year 2022, researched the figure of 7,844 million soles, which is around $2,100 million and 1,600 million pounds. All this destined for development of the regions of the country. The objective of this article is to present the integrated approach to cost management and optimization of operations in the mining industry. This article seeks to give its sustainability to its operation. To this end, directing the industry for and resource to innovation and continuous improvement of this process requires having an adequate management and cost control tool. Methodology. The methodology used in this study is based on a systematic review of the literature, following the guidelines of PRISMA approach, preferred reporting items for system reviews, and meta-analysis. That's the meaning of PRISMA. This methodological approach makes it possible to guarantee rigor and transparency in the selection analysis of relevant studies. Search criteria, thematic relevance. Thus, a study that directly addresses the issues of cost management and optimization of operations in open pit and underground mine were considered. Next, the methodological quality preference was given to those art studies that present a solid and rigorous methodology based on previous research, empirical data, and adequate analysis. Then, the contribution of the field to the field of study, articles that provide new knowledge, innovative approach, or best practice in cost management and optimization of operations in the mining industry were selected. Accuracy of the studies. The most recent works in the last decade were prioritized to ensure that the information and findings were developed and reflected current trends in the mining industry. A total of 40 articles were reviewed from databases like Google Scholar, Request, Dialnet, Scopus, Alice, and Redalyc, following the PRISMA approach to ensure rigor and transparency in the selection and analysis of relevant studies. While while quantitative techniques were used, patterns in key terms of the mining industry were identified. 26 articles focused on mining optimization, proposing methods to maximize productivity and reduce costs. 44 stud no, claro, 14 studies centered of resource management, including transport efficiency, man- maintenance, and cost. 20 articles address supervision and control, improving areas like planning and indicator monitoring. Additional 17 articles tackle time optimization in mining operation. The choice of equipment was discussed in 12 studies, evaluating productivity and profitability. Continuous work and learning was identified in 6 studies. In design and planning, 19 studies propose models and methodologies to optimize operations. These stems gathered from the 40 articles emphasized a significant focus on mining operation, optimization, and control, suggesting the need to diversify approach to address challenge in the industry. These are the proposals of different authors to solve the problems that we'll see in the next table. Table 2. Problems that the authors propose solve. This table, as we can see, the most frequent problems for which the review authors propose the solutions seen in the table 1 are A. Low productivity. Low. Poor time control. C. Incorrect short and long-term planning. D. Inadequate selection of equipment. E. Poor consumption of resource. F. Poor drill and blast system design. G. Reduced production volume. In addition, the symbols cross, heap, and zero were used to determine the following. X address the problem in its entirety and propose specific solutions. A hyphen approach the problem tangentiality, that is something secondary but equally important. And zero does not address the problem. So we can see that out of the 20 authors, some have focused their efforts on mitigating low productivity through specific plans for many tasks, highlighting the importance of clear protocols and effective time management. Another 14 authors have proposed solutions to enhance time control and reduce costs by optimizing input usage. Inadequate planning, 23 authors suggest preventive enhancement to avoid issues like inadequate ventilation and accidents. Equipe selection has also been tackled by 14 authors to circumvent costly reimplementation. Inefficient resource consumption, such as food, has been addressed by 8 authors. Incorrect design of drilling and blasting system is addressed by 12 other authors with alternative approach. A recurring issue of lower than expected production has been tackled by 14 authors. Next, can you see the table number 3, methods and tools used to solve problems. Table 3 shows a compilation of various studies in the mining industry, highlighting the applied scientific method, the using of technology tools, the application of mathematical models, statistical analysis, and systematic review. The authors have used a variety of tools and programs such as Minitab, Arena Simulator, Python, Doppler, and PCBC, among others. They address challenges in the mining industry. They also apply mathematical modeling and statistical techniques to optimize production, improve cost management, and make informed decisions. This approach and tools have made it possible to improve efficiency, increase productivity, and reduce costs in mining operations. Conclusions. In summary, the qualitative analysis of the reviewed articles highlight the technology's crucial role in improving operational efficiency in mining. Research suggests diverse technological solutions to optimize operations, increase productivity, and cut costs. These solutions enable accurate real-time monitoring, data analysis, and predictive models to inform decision-making. The integration of such technology enhances drilling and blasting design, leading to higher productivity and reduced costs. Overall, embracing technology proves essential to overcoming challenges and enhancing mining effectiveness. Thank you to all.
Thank you for your presentation. If the session chairs are having any questions, then you may ask.
I have no question. Thank you.
Anyone else having any questions? Okay, thank you for your presentation. Let's
Thank you.
move to the next one. I think Koscherev has joined us. So I would like to request him to share the screen and start the presentation.
Hello, nice to meet you. And I will start my presentation. Give me a second, please. Okay. It's demonstration. Can you give me a possibility to demonstrate my presentation?
Yes, you can start.
Okay. Okay, now I see. Our scientific work is called analysis of the problem of forecasting in proactive enterprise management. We'll start from introduction because we are working with big plants and with different production plants, and this industrial enterprise and plants manufacturing diverse goods, services, and so on. The main enterprise goals today is stability, growth of business, profitability, labor productivity, and sales volume. The possible management type which exists today, it's active management, it's set market trends with innovation, and passive management, it's adapt to market changes. If we are talking about proactive management, it can give us possibility to predict and address issues before escalation, before it happens. And here you can see different technicals which help us with work with proactive management. And the most important thing in proactive management is forecasting. It's like key to anticipate or to adapt to different market changes or to production changes. And it's very important because today we are living in a world with industry 4.0 or even industry 5.0 in production world. It's automation, digitalization, and human machine interaction. So the forecasting is one of the important things. It can be used in this high technology world for the production plants and so on. The main target, the main aim of our work, it's to grow up the efficiency of industrial plants operation directly, and we understand that it directly depends of the resources and from energy consumption, like gas, water, electricity, chemicals, and other. If we are talking about that in this context, the issues of accounting, assessment, and forecasting of using the enterprise's energy resources consumption, it's very important for the profitability and for final price of the goods or services production on these plants. In this work, we are talking about the creation of forecasting model for a specific system. I will present it below, which can give us opportunity to forecast the resource consumption for future periods based on both data collected from the previous periods and the current and anticipated external factors. It's like production parameters, indoor and outdoor temperature, humidity, and so on for our specific system, EcoFlex. It's the system, it's enterprise system. I will present it below, but currently it works for 100 Ukrainian plants, and it works successfully. I will show it below. So for creation of this model, we use the different mathematical models like Holt, Brown, additive, autoregression, and for potential software expansion of system web interface, which can perform calculations in the cloud on the server side and provide users with data on forecasting consumption and particular type of energy resource. Some words about the EcoFlex system. It's the system which gives us opportunity to collect the data from different sources. If we are talking about energy, it's a monitoring energy resource consumption. It's automated. It has an opportunity to have automated collection, accounting, and data storage in cloud, as I talked before. It provides analytical information both for enterprise and for individual units. The proposed solutions, its integration of enterprise resources meters into a common digital network for centralized data collection and processing. Through a cloud-based web interface and mobile interface, it's possible to monitor the enterprise's energy consumption from any device. So you can control your consumption even using mobile phone. All one needs is an internet connection, and you must be, of course, you have an installation of hardware and software parts on your plant, and you must be registered users with appropriate rights to have an access to archive and to different possibility of the system. So you can see here that industrial embedded system EcoFlex using to unify and centralize control over production architecture to reduce equipment maintenance costs, to optimize the production line performance and capability, and to monitor energy and production resources. It has a possibility to create in real-time enterprise energy and equipment balance sheet, tracking energy cost per units, integrated data from various sources, as I talked before. It's electricity, steam, gas temperature, and so on. It's providing full-time access to dashboards, so different type of dashboards, and it's unifying data from different industrial hardware and software system into one single digital solution. So here you can see the structure of EcoFlex system. Let me tell you something about that. So we can see different energy resources, different equipment, different types of production data, temperature and humidity sensors, oil consumption sensors, and so on, different type of sensors. We have an universal solution for that. It's connected to the controllers, and then through these controls, it's coming to industrial computer based on Raspberry Pi. Or even other counting system can be connected to this industrial computer, which installed on site. Then it can be connected to a cloud-based server with services for all clients. It can be connected externally to ERP accounting system, and it has a forecasting model which will be presented below. And we have different user roles, as you can see here, like administration, technical management, finance department, and so on. And they have only the needed data from the different controllers, from the different sensors, and so on. It depends from their targets and from their plans. Here you can see the web interface of the system. So this you can see different types of data and digital data. You can compare the different parameters and so on. It's really a huge system, and it will be a pleasure for me to present it whole system, but I think we have no time, and better if we can focus to this forecasting opportunity on this forecasting model. By the way, we have EcoFlex here for manufacturing resource planning, MRP. So this is a possibility like monitoring energy resources, production resources control, procurement management, and auditing about limits and deviations. It's also very important function of the system. So let's talk about the forecast results and comparison with real data. Here you can see the results of the working of this model. These mathematical models describe the actual process of energy consumption on a plant and allows making a forecast for consumption level based on data collection during the previous periods. The model should take into account the changes in external factors, its production parameters, temperature and humidity inside the plant and this external environment. I will show it below on next slides. The software model for information modeling of the forecasting process may be implemented by Holt, Brown, additive auto-regression and regression models. And I will show the comparison between these different models. It depends from different conditions, but for our opinion, auto-regression it's the best result, but it's sometimes we will try to adapt different models depending on the data. As you can see here, examples show the forecasting results by additive model. Sorry, not auto-regression, additive model will be most effective here. It's my mistake. So on this chart, you can see comparison with real data. So the actual real data, it's marked by red, and forecasting data marked by black. And the deviation is not so big, as you can see from this chart. So the main forecast problem. It was installed on some poultry plant. It was integrated to this EcoFlex system with the sensors of temperature and humidity. And if we are talking about this plant, the core function of this plant of enterprise is poultry breeding. The ultimate goal is to breed poultry for various products. We have very high importance of forecasting for this plant, because it's very critical for them to understand the future period gas consumption, and the price depends directly from their pre-ordering of this gas for heating of the plant. It helps to planning the, as I told you, it helps to planning of purchase and consumption gas through the all production states. And we are talking, if we are talking about this industry of poultry industry, this sector has multiple levels, and process within this sector is very important to have an opportunity to forecast and to monitoring all the processes, including the consumption of the gas, if we are talking about this example. Some words about the production process. There is different stages. It's like warming of the space, poultry placement, from placement to slaughter is spinning over some days, process, and after that it coming to the process reiteration. And the main objective here, with known data from the previous days, the goal is forecasting gas consumption in the facilities units for upcoming days. They aim to construct an automatic gas consumption forecasting model for enclosed space. So external factors, as I talked before, it's air temperature external, it's ambient humidity, it's cloud cover, it's atmospheric pressure, and daylight duration. We are talking about environment condition which taking place in our model. Facility condition, it's room temperature inside, it's different room parameters like temperature, humidity, ventilation, and so on, and different technological parameters connected to the poultry industry. And different data characteristic. Each mentioned factor is either approximated or determined based on the specific observations. Observations are taken at regular intervals, minutes, hours, days. So it means that we have an amount of the data based on the monitoring, based on the data stored in our system Ecoflex, and based on previous periods, we can build our forecasting model. So let's talk about the forecast mathematical model. As you can see, employed mathematical forecasting method utilized our daily gas consumption data. It's our approach, and generated predictions for the next day, or even several next days. Short-term forecast for subsequent days also can be realized without any general limitations. As you can see, here we connect to Ecoflex system and create the software model for information modeling of the forecasting process. And previous slides, it was shown the results of working on this model. And on the next slide on the table, I will show you different data comparison. We're using different models in our model. It presents the gas consumption modeling outcomes based on Holt, Brown, additive, auto-regression model, and comparisons are made between the model result and previous measured data. The results are all for determining a correction coefficient for each model, and derive an analytical expression for prediction resource consumption parameters for future periods. And of course, evaluation. It's most important things. It's cost effective, and it gives the savings to the production plant. Forecast results is compared with measurement from the previous day or even previous days. Overall gas consumption using the applied methods can be determined by introducing corrective coefficients. So this is the modeling results. As you can see with different models, it's measurement, it's deviation, standard or approximation errors, Holt model, Brown model, and regression and auto-regression. So in our case, here, as you can see, the additive model was most effective. This is a chart for additive model. Sorry, that's in Ukrainian, but you can see this for additive model. It's for Holt, it's Brown model, it's regression and auto-regression. So additive and auto-regression give us close results, but additive model here on this data set is better. And as you can see, these things and this approach was very effective for this case. It was also installed for in other plants, and this approach was used for oil prediction consumption for brewery plants. It was used for electricity prediction consumption for meat production plants, and so on. So we have a long story here in Ukraine of implementation such model. And this development forecasting model is tailored for prediction future resource consumption. It incorporates previous collected data on consumption, temperature, humidity, and other factors. And it's also includes potential production data. And of course, based on the production data of previous periods. So here is an analysis of numerical results. For this case, hot model integration forecast have the lowest average approximation error, and conclusion at the end of my presentation, I can say that based on the analysis, this approach can be formulated for forecasting energy consumption, considered different parameters and adjustment coefficients. This is some words about our next ideas and the future development of our system. We provide a new forecasting approach. We are using centralized data collection in a cloud architecture. We can offer the automated data processing. We deliver both direct data collection results in digital, tabular, or graphical form, and forecasting data based on the work of our forecasting model. And also we have an opportunity to flexible export data to external system like MS Excel or in XML format, or even integration with different types of CRM or ERP systems. Using this model for EcoFlex monitoring information system gives a very big amount of saving for real customers. And of course, we are talking about of increasing of forecasting of prediction quality using mathematical methods and of course AI methods too, because AI for us it's a new story. We are working on it for last year, and I hope that in nearest months we will add AI possibility to forecasting to our models too. Thanks for your attention, and I am open for your questions.
Thank you so much for your presentation. If the session chairs are having any questions, then you can ask.
Yes,
Yeah.
I have one question.
Yeah, please.
Can you please go to the slide number 10?
Give me a second, please. Oh, this one.
Yeah,
Yes.
this one. So I just wanted to know, see, there's a difference in the values of the predicted one and the real one, but this difference is non-uniform. Can you specify the reason why this non-uniformity is there in the graph?
It's a very interesting question, because it's a result of the working system, and I think maybe I need to check it why it's not so uniform. I don't know exactly this actually, because we need to check it. We need to check
because,
it.
you know, if you're working on a particular system and you're comparing it with the real data, then and if the results are showing non-linearity and difference is
Yes.
similar, then we should find out the reason actually. Thank you. That's all.
Okay, we need to check it. I think I will ask with my co-authors who is more responsible and better understanding of this mathematical model, why it's not so linear. But I think it depends from different coefficients. And yes, you can see the difference here. It's also a little bit strange for me, but as you can see, it's more or less close to real data. Next question, please.
Okay, so I have just a few questions. So first, I just wonder, like, do you have any idea why Hout method provides the least error? Okay, and is there any limitations in this work? And what would be the approach that you like will propose for the next work to improve it?
Okay, so I try to answer to a question about the approach. So our approach to create and to increase the quality level of this model, and our approach to implement it, as you can see from my previous presentation, for different industry, to provide them the possibility to make a forecast of their resources, and as a result it will be the savings based on this model. And the next step for us, as I talk at the of my presentation, it's implemented of AI, but now we are working on it. We are trying to implement it in combination with different type of model, code additive, and so on. And we have a first results here, and the quality increases up to 5% using the AI, even more.
Okay, so you will like explore more of the AI methods.
Yes,
right?
yes.
Okay. Okay, thank you.
Thank you.
I would request Gargi to kindly take note of the timings. Actually, we are exceeding the time, so just interrupt the presenter if the time is over.
Yeah, sure.
Okay.
Okay, thank you for your
Okay.
presentation.
Thanks for your attention. Have a nice day. Thank you. Thank you.
Thank you. So let's move to the next one. The next we have is ERP integration, enhancing collaboration in virtual and extended enterprises, and that will be presented by Usman Ahmed Usmani. You can share your screen and start the presentation.
Yes, just a minute. Can you hear?
Yes.
Just. Hello, the title of my presentation is ERP integration, enhancing collaboration in virtual and extended enterprises. And my name is Usman Ahmed Usmani, and I have done a PhD in information technology from University Technology Petronas, Malaysia. So coming to the contents, we first go to the introduction and context, and then the importance of ERP integration, and then the collaboration, virtual and extended enterprises, and then we give our proposed framework, and then we discuss about the benefits of ERP integration, and then overcoming the collaboration challenges, and then further we go to these challenges and best practices, and then the future trends and the conclusions. So coming to the introduction context, in the age of digital transformation, uh, effective collaboration and seamless communication have become imperative for business to stay competitive. And the significance is that they offer improved visibility and control over various operational aspects and integration challenges. Uh, Despite the advantages, integrating ERP systems remains a complex challenge. And as business expand globally and adopt the virtual structures, the need to collaborate efficiently across departments become increasingly critical. And ERP integration has emerged as a solution to enhance the collaboration and communication among different parts of the organization. And it leads to basically improved decision making, streamlined operations, and optimized resource utilization. And it includes the utilization of middlewares and APIs that serves as a best practice for integration. And cloud computing is explored as an enabler for ERP integration. And in terms of data governance and security, as data becomes central to operations, maintaining proper data governance is important. And to realize the full potential of ERP integration, business must adopt a comprehensive approach that combines technological solutions. And ERP integration enables a smooth exchange of data across different departments, and they provide a comprehensive view of the organization operations, and they optimize the workflows, automate repetitive tasks, and eliminates manual data entry, leading to improved operational efficiency and increased productivity. And integrated ERP systems offer real-time access to critical information, empowering the stakeholders with up-to-date insights. And it fosters collaboration by connecting departments and teams, enabling effective communication and streamlined coordination. And integrated systems allow business to better understand the customer. Now, coming to the importance of ERP integration, they allow business to better understand the customer needs, preferences, and purchase history. And they optimize the supply chain by enabling better demand forecasting, inventory management, and supplier collaboration, which results in reduced cost and faster deliveries. And they assist in maintaining compliance with industry regulation and standards. and they minimize the need for disparate systems, and they provide a flexible foundation that can adapt to changing market dynamics and business requirements. And coming to the collaboration in virtual and extended enterprises, coming to the geographical dispersal, they span multiple locations, making effective collaboration essential for seamless communication. And they bring together individuals with diverse skill set and expertise from various locations, and they enable the formation of cross-functional teams. And in terms of global partner networks, they often involve external partners, suppliers, and customers, requiring robust collaboration platforms to manage the relationships effectively. And they allow for around-the-clock interaction, catering to different time zones and enhancing productivity across global teams. And they reduce the travel costs, and digital tools and platform enable the real-time communication, document sharing, and collaborative workspaces, and adaptation to remote work, where the virtual collaboration aligns with the growing trend of the remote work, supporting employees in staying connected and productive from any location. And they require understanding and respecting diverse locations, promoting effective communication and mutual understanding. So all these points we gained after critical literature review. And in terms of agile decision making, collaborative efforts in virtual and extended settings facilitate the agile decision making by allowing rapid consultation and consensus building. And the benefits of ERP integration is that they eliminate the redundant process, and they ensure consistent and accurate data across all departments, and they provide a unified data source enabling comprehensive and real-time reporting, and they offer a centralized view of business operations, and they reduce manual labor, lower administrative costs, and optimize the resource utilization. And they provide customer satisfaction and efficient inventory management, and responsive decision making, where they can respond promptly to market changes, and they help maintain compliance with the industry regulations by ensuring accurate and accessible record of operations, and they offer a flexible foundation that supports the business growth, allowing organizations to scale efficiently. So coming to the overcome, how we can overcome the collaboration challenges is in terms of communication barriers, implement clearer communication channels and tools to bridge gaps caused by the virtual and extended setups. In terms of time zone and differences, we need to establish shared working hours or staggered shift to accommodate team members in different time zones. And we too need to foster cultural awareness and sensitivity to provide effective communication, and utilize video conferencing and virtual meeting platforms to simulate face-to-face interactions, and implement organized information sharing system to prevent overwhelming team members with excessive data. So this is our proposed framework where we address the interoperability and cybersecurity challenges in the Industry 4.0 asset management. And this is how the ERP integration, cybersecurity measures, collaboration, and standardization, these are all interlinked together in an Industry 4.0 asset management. And then overcoming the collaborative challenges, there are some data security concerns where these challenges can be addressed by implementing robust encryption authentication, and providing training and support to ensure team members are comfortable, and then clearly communicating project goals and objectives to ensure everyone is working towards the same outcome. And in terms of task coordination, implementing project management tools and methodologies to track tasks, and lack of trust, the foster in terms of lack of trust, we can increase the trust through transparent communication, regular updates, and recognition of contribution from remote team members. And in terms of diverse organizational cultures, communication coordination can be hindered by differences in the cultures and structures, and handling intellectual property and confidentiality becomes complex due to varying experience levels and expertise of partners. And establishing trust is vital but challenging when partners are geographically dispersed or lack shared experience. And sharing sensitive data poses challenges related to data privacy, and developing a common vision and aligning goals ensures that all partners work cohesively towards shared outcomes. Defining clear roles and maintaining open communication channels to keep partners connected, and establishing clear guidelines and protocols for managing intellectual property, and implementing robust cybersecurity measures like encryption and access to safeguard shared data, and clearly defining each partner responsibilities to avoid confusion. And the future, coming to the future trend and conclusion, ERP systems will increasingly incorporate AI for predictive analytics, and blockchain technology will enhance the transparency and traceability in extended enterprise supply chains, improving trust and reducing fraud. And Internet of Things integration with ERP will enable real-time monitoring of assets and process. And collaborative tools will continue to evolve, catering to the changing landscape of remote and hybrid work environments. And ERP system will leverage data to offer highly personalized customer experiences, enhancing the loyalty and brand reputation. And these are some of our references from the paper. So we did basically a critical literature review and then gave our proposed framework uh, for extending ERP integration in virtual enterprises. And these are some references. And thanks for listening to the presentation. Your questions are most welcome.
Thank you for your presentation. If anyone is having any questions, then you can ask.
Your research was mostly theoretical review of integration and their advantages and outcomes. Have you adopted
Yes.
or have you identified or reviewed different methods to integrate ERP? Have you reviewed
Yeah,
methods also?
Yeah, after reviewing the method, after reviewing some of the method, then we gave what can be the challenges or what can be the future, or what can be the challenges, and what how can we give measures to combat those challenges.
Okay, because those methods were not mentioned, and the comparison of those methods are also not there. Outcomes are there already. Okay, thank you so much.
Yes. Thanks, Leo.
Any further questions? Okay. Thank you for your presentation.
Thanks.
Let's move to the next one. So the next paper is Sensing Devices Digitize the Texture of Fabrics for Sustainable Fashion. And this will be presented by Tesai Kawasaki. You can share your screen and start the presentation.
Thank you. Good morning, good afternoon, and good evening. My name is Taisei Kawasaki from Japan. I will now begin my presentation. Look at this picture. This picture looks like Asahikawa in winter. I'm a Kosen student. National Institute of Technology is Kosen. What is Kosen? In Japan, popular steps are junior high school, senior high school, and university. You know that after the university comes the master's program and the doctor's program. By the way, Kosen steps are junior high school, National Institute of Technology, Kosen. It is into 3 steps. First, tensor for university. Second, go on to advanced course of engineering. Last, employment. I'm now. Let me introduce myself. National Institute of Technology, Asahika College. Department of Electrical and Computer Engineering. 3rd grade, 18 years old. Same grade as senior high school student. I came from Asahikawa, Hokkaido, where there is a lot of snow and a big difference in temperature. This is the first case of a senior high school student from Asahikawa presenting at the international conference. This research was supported by the Tonnage Science and Technology Scholarship Foundation, about $14,000. This funding is for senior high school students whose research is based on original ideas about science or technology in order to support the development of academia, science, and technology. Agenda. First, background. Second, what is young count and peak span inch? Third, aims. Fourth, related work. Fifth, method. Sixth is research result and discussion. Seventh, conclusion and future work. Eighth, reference. I'd like now start today's agenda with some background. First, energy consumption is high in fashion industry. For example, manufacturing, air, disposal, and so on. Second, fashion has a short life cycle. Internationally noted as an industry with a very large environmental impact. Sustainable fashion is rare. In order to make fashion goods, 180 million pieces of clothing disposal in a year. Planning products to be sold a year in advance. Then, unpopular waste fabric occurs. So, our research innovates manufacturing flows in the fashion industry. Can we digitalize the fabric fabric? Merits of going digital. To update quickly and save manpower. However, digitalize the fabric sketchbook has their issues. Judging by human senses, for example, squaring and softness. Next, what is yarn count is pixels per inch. Yarn count is line board. Superfine yarn is top pressure dress shirt. Extra fine yarn is luxury dress shirt. Fine yarn is dress shirt. Regular yarn is casual shirt. Next, pixels per inch is the number of warp and weft yarns woven. And this texture is 98 lines per gazette. The next texture is 136 lines for an apron. The last texture is 180 lines for a bedsheet. This research focuses on pixels per inch. Next, aims. Our research innovates manufacturing flows in the fashion industry. First, digital transformation fabric softness. Our research digitizes the pixels per inch using voltage and resistance values. Second, improvement of the device to facilitate its use. Our research develops the user interface elementary. Next, related work. Seniors by 4 years at our college developed the prototype model. Our research used this prototype to make fabric properties. Next, method. The method is 4-step process. First, hypothesis. The fabric and crepe are elastic if no permanent deformation occurs. Second, validation method. Clip the fabric between the clips to see the voltage and resistance value. Third, experiment. If the voltage or resistance values are not constant, it is an elastic body. And if it becomes constant, it is not an elastic body. Fourth, errors. Compare the measured and theoretical values to see the error. Next, research result and discussion. Our research created the user interface that displays the voltage and resistance values of the fabric properties. This interface have two buttons. Start button is the start measurement. Stop button is stop measurement. They are simple action. This texture has the curve of voltage and resistance. Voltage and resistance values always produce the constant waveform. Then, this is an error, but this result has little errors. The theoretical values of stress in this equation. This table shows the results of the validation. This is edge of pillow. This texture have a curve of voltage and resistance too. Voltage and resistance values always produce the constant waveform too. Then, this is the error, but this result have little errors too. The theoretical values of stress in the equation. This table shows the result of the validation. Next, conclusion and future work. This research achieved two aims. First, fixing fabric softness. The maximum and minimum values of the voltage and resistance shows the pixels per inch. Second, improvement to facilitate use of the device. The system displays the maximum and minimum values of voltage and resistance using calculation. In the future work, our research want to try all texture to reduce fabric waste. Last reference. There are references. Thank you very much for your attention.
Thank you for your presentation. If anyone is having any questions, then you are open to ask.
Yes, I have one question.
Yes.
Whenever you give voltage to some, like fabrics are mostly, we consider fabrics in the class of insulators, right?
Pardon me, please.
Fabrics are mostly considered, as you know, there are three classes: insulator, conductor, and some magnetic material and other materials are there. We consider fabrics as insulator basically. So I have a question that if we are giving some voltage and some current is flowing through it, and by knowing the resistance value or by calculating the value of resistance, we are going to identify what kind of fabric it is. Then the resistance will depend upon so many other factors also. I could not understand how actually we can calculate the the fabric thickness just by knowing the value of the resistance. Can you please go to slide number 16?
16, okay.
1, 6,
Please wait. Yes.
Now go to the result part where you have calculated resistance and the graph.
Yes.
Yes,
this page?
yes, this one. Now, for
yeah.
this particular fabric, you have applied some voltage and some current will flow there through it, and you have calculated the resistance of by knowing the ratio of voltage and current. But how would you find out the type of fabric if you know the resistance of if you know the measured resistance, can you please clarify this?
The higher the movement of stress, the softer the fabric. In this research, the movement of stress was found from voltage and resistance values.
Okay, thank you.
Thank you.
Okay, I just have a quick question. Do you have like the comparison of the results with other works, of your results with other works?
Pardon me, please. Sorry.
Yeah, I just would like to know that like your proposed method is, you know, outstanding, or it achieved like any greater aspect compared to other works, because I didn't see any, you know, comparison from the experimental results. Yeah. Yeah, that's okay. I mean, like next time when you present a work in a conference, so you should have some, you know, some tables, and then you show the comparison between your proposed method, okay, with other state-of-the-art works, so that we can see how, you know, how significant of your work is. Yeah.
Anyone else having any questions? Okay, thank you for your presentation. Let's move to the next.
Thank you.
So the next paper we have is Strategy to Identify Knowledge Management Solutions for Startup Companies, and this will be presented by Titik Vihayanti. You can share your screen and start the presentation.
Okay, thank you. Okay, let me introduce myself. My name is Titik Vihayanti. I am first author and as presenter, and author team is Muharman Lubis, PhD 80, and Dr. Basuki Rahmat. We are from Telkom University, Indonesia. The paper is titled is Strategy to Identify Knowledge Management Solution for Startup Company. In 2022, Indonesian startup companies continue to grow until reach 2,346 startup companies. Indonesia ranks fifth in the number of startup companies worldwide. This is data from databox.com, 10 countries with the most startup in the world, and Indonesia ranked in the fifth. Although not all startup companies are successful. Based on data from the Ministry of Communication and Information Technology, Indonesia, there are 1,300 startup participating in a program called 1,000 Startup National Movement, but only 10% still survive. And this is some of report from online media reporting about the failure startup in Indonesia. Startups face many challenges and factors that can affect sustainability in early stage of development. Some of the factors that cause startup in Indonesia go throughout are lack of funding, no market needed, flawed business model, and ill-timed products. To survive and achieve sustainable success, startup company must be able to continue to innovate both in product development and business strategies. One of the way to get the success by utilizing organizational knowledge management through a knowledge management or KM approach. Startups are agile organizations with dynamic capabilities that are used to take different risks. And knowledge management is one of the management practices that can support the dynamic characteristic of agile organization. However, implementing knowledge management in startup companies has challenged, mainly related to how KM implemented according to startup unique organizational characteristics. As a growing company, startup generally has limited human resource and simple organization structure. Organizational decision making is based on intuitive. Startup also has team consisting with a different knowledge and background. So before implementing KM, it is necessary to develop a strategy to identify what kind of KM solution is suitable for challenge and characteristic of startup company. This is the objective of the study. First, the study aims to develop a strategy to identify knowledge management solution that suit for startup company organizational characteristic, and also to provide valuable insight for startup companies on how to identify and manage their knowledge more effectively so it can help to improve innovation capabilities and sustainable growth. The methodology, the study used a literature approach to identify for determining knowledge management solution for startup. Literature study are used to understand first startup organizational characteristic and the concept of KM solution and the importance of implementing KM management for startup from related work or related study. This methodology includes searching and analyzing literature relevant to this research topic, including literature in scientific journal, article, and from books. And the data obtained are used to develop a strategy to identify KM management practice to support growth and success for startup. The result of this research are expected to provide a guidance for startup companies in identifying KM solution applied according the needs and characteristics for their company. Result and discussion. First, we will discuss about startup characteristic. As an early stage of development company, startup have several characteristics that distinguish them from small companies such as SMEs. Based on the conclusion from some study, startup have a characteristic that classified in 4 dimensions. First, organization, ownership, strategy, and innovation, and in financial. You can see in the table, organization characteristic, small scale organization, young age, until centralized. Ownership is owner manager and direct supervisor. Strategy and innovation, niche marketing strategy, past innovation, lack of product research. And financial, startup usually funding from personal saving or from relative. And then benefit implementing KM for startup based on related work or previous study. As a company who operates in dynamic and challenging business environment, startup must adapt and innovate quickly so they can survive in long term. Several previous study has stated that startup can utilize KM to overcome this challenge. As stated by Antelova, first, customer relationship management support the process of sharing knowledge with customer startup. Startup can success through the alignment of KM strategy, long-term business goal, and efficient use of information and communication. Other studies confirm their startup company tend to face relative low barrier to implementing KM. This may due to startup strong focus on innovation, proactive attitude, motivation to overcome any challenge that arise. Thus, it can be concluded that knowledge management can be a powerful organization tool to support change process because it provides a continued flow of information to organization for the better decision making. And next, knowledge management solution concept. Knowledge management solution is a concept which is implementing KM can be comprehensively facilitated. The concept of KM solution can be seen in the picture. Knowledge management solution include knowledge management process and system, knowledge management mechanism, and technology and infrastructure. To facilitate comprehensive implementation of KM, corporate organization can refer to this KM solution. The company organization can determine the kind of KM it is aligned with its characteristic and then determine what KM system can be facilitate the process, including startup by observing characteristic of organization. And this is the strategy as the result of this paper in identifying the need of KM suitable for any company. Strategy need to be implementing. The methodology that used in this strategy is adopted from the concept of KM by Becerra Fernandez and Saberwal. The strategy contains 6 phases that need to be carried out by company to identify KM. The first strategy is assess contingency factor based on startup characteristic. Contingency factor is a circumstance or situation that is expected to occur soon but may not occur. The first stage by assessing the organization environment in terms of contingency factor, such as task, knowledge, environment, and organizational characteristic, and how this factor contribute to uncertainty. The second phase is identifying KM process based on each contingency factor. And
sorry to disturb you, Titik. 10 minutes are almost done. You have only 2 minutes, so kindly conclude your presentation.
Okay. 3, identifying existing KM process. 4, defining the KM process required. And the number 5 is defining the KM infrastructure. The 6 or the last phase is developing the KM required by the company. This is the table that can use by company to identify the contingency factor. Cumulative priority score with number higher can be considered as a KM process that can be adapted by company to prioritize in KM system that will be developed. And the conclusion, start up a dynamic corporate organization that face many challenges but have great potential in terms of innovation. By utilizing a knowledge management approach, startup can develop their organization potential to improve their organizational capability and achieve sustainable. To support KM utilization, startup can use concept of management solution to determine strategy to identify the KM process. In addition, considering that startup are growing companies, the identification strategy also expected to provide cost efficiency in the KM implementation process. Thank you.
Thank you so much for your presentation. If anyone is having any questions, then you can ask.
Yes, one question. Titik, I would congratulate for such a lovely presentation. I like your presentation very much. I have one question. Is this KM structure or strategy applicable to any country, like the startups of any country, irrespective of, like you have presented a case study of your country. Is it applicable to all the countries?
Yes, applicable. Because the strategy is customized, can use in any startup, but limited in this study is not yet applicable. This is first apa namanya? A first try from me to use this strategy, but this is not yet implemented in startup. But maybe in the future, startup can use this strategy to identify a KM process that can be applied in their company, any startup in any country.
Okay, thank you so much.
Okay, any question?
Okay, thank you for your presentation. So we are just left with one presentation, that is a reinforcement learning model of a dynamic solar panel system for maximum energy harvesting. Is the presenter there? Okay, no issues. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 7th version and all the previous 6 versions of the conference. We will be happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2023. And I would also like to thank our session chairs, Dr. Pallavi Bhatnagar and Dr. Thaitabon Genokritana, for chairing the session. A token of appreciation to the chair on the behalf of the team World S4 2023 and Global Knowledge Research Foundation and partners. Thanks to both of you. If you want to share your reviews for this session, then you can ask.
Thank you, Gargi. It was, hearing presenters from different countries and different areas. It was a pleasure being here and sharing this platform with my co-chair, Thitapon. It was really a nice pleasure. And thank you very much for providing me this opportunity to listen to such innovative research which is going on, being presented by a different presenter in a very interactive way. Thank you so much.
Okay, I also thank you so much for inviting me as a session chair, and also thank you, Professor Pallavi. Okay, for I think we like for the presenter as well, so we also get comments from Professor, and actually for the presenters, I think is when you present, I would like to get more of the details of your work. Yeah, so in some work, I think you have like a lot of information, but somehow you put it like too much in slides. So maybe like next time you can adjust it to be like easier to read and yeah, so I can follow the content precisely. Yeah. Anyway, thank you for your presentation. Yeah.
Thanks to both of you for sharing the feedback and reviews. And at last, I would like to request you all to please turn on the camera so that we can take a quick snapshot. Okay, thank you so much, everyone.
Thank you, Gargi.
Thank you.
Have a good day, everyone.
Thank you.
Have a good day, everyone. Bye.